We are now finally ready to apply everything we've learned to constructing algorithms for triangle congruency and similarity. So before we actually set up the flowcharts for those algorithms, we need to agree on how the sides and angles are going to be paired up between one triangle and the other triangle. In some mathematical descriptions, you may find words like corresponding sides must be equal or corresponding angles must be equal. In order to express this in an algorithm so that a computer can process it, we need to provide clearer labels on the sides so that the computer can understand exactly which corresponding sides and angles it means. So let's start by labeling the sides and angles of a triangle. We're going to label the sides and order them from shortest to longest. So if we are comparing two exactly the same triangles, the shortest side will always be the same, the longest side will always be the same, and the second shortest side would always be the same. So let's find our shortest side, and we're going to call this side A. And it's important to note that A is always going to be associated with the shortest side. We're not just going to randomly pick a side and call it A. The side A will always be tied with the shortest side. The angle that is going to be opposite the shortest side, we are going to call small a. And this is really important because this is the way we're going to identify angles. We're not just going to pick any random angle and call it A. The angle small a is always going to be opposite the shortest side, which is capital A. The second shortest side we're going to call B, and the angle opposite the second shortest side will be called small b. And lastly, the longest side we're going to call C, and the angle opposite the longest side is going to be small c. So here's everything together. And so we can see how we can apply this with two different triangles. Side A in triangle 1, you can see matches up with side A in triangle 2. So that's pretty straightforward because the triangles are exactly oriented or rotated in the same direction, so you can obviously match them up very easily. But you can imagine the case where if the second triangle was rotated a little bit, it may not be that obvious to you, and it will definitely not be obvious to the computer unless you say that A is the shortest side in both triangles, and you can then see that that's where they match up. We're using the length of the sides to match them up across two different triangles. And here we see two similar triangles, and it works the same way. So if we have that angle there, what is the corresponding angle in triangle 2? The maths textbooks may just say find the corresponding angle, but that may not be obvious to a computer at all. So let's take a look at triangle 1. That angle that we're trying to find is opposite this side there. And that side there is the second shortest side in triangle 1. And you can see that just by measuring the three sides. So now that we know that that angle is opposite the second shortest side, we know that is the angle B. So how do we find the corresponding or the matching angle in the second triangle? Well, we do the reverse. So we start with the second longest side in triangle 2. So that would be that side. So that would be the B side. So the corresponding angle would be the angle that's opposite the B side, which is small b, which is that angle. So then we know those are the two corresponding angles that match up between those two triangles. When we have a right angled triangle, we're going to use A for the shortest side, B for the second shortest side, and H for the hypotenuse. And now we are ready to look at some congruency algorithms. So we're not going to go through all of these because there are so many different combinations of congruency and similarity algorithms. But for example, the very first one, which you may know, is the congruence by side, side, side. So if all three sides are equal in both triangles, then you know that both triangles are congruent. So the way this algorithm works is we're going to ask the user to type in side A, side B, and side C for triangle 1. And we're going to assign them into three different variables. Then we're going to do the same thing for triangle 2. Ask them to type in side A, side B, and side C for triangle 2. And then we have this compound decision step here, where we're going to check whether side A from triangle 1 is equal to side A from triangle 2, and side B from triangle 1 is equal to side B from triangle 2, and side C from triangle 1 is equal to side C from triangle 2. And if all of those three sides are equal, then we know the two triangles are congruent. Otherwise, they are not congruent and our algorithm ends. We've got 6 input instructions to gather 6 variables from the user. That is 3 sides from one triangle and 3 sides from another. And then we do this big compound decision step where we check that both sets of 3 sides are equal, and then we can determine whether the triangles are congruent or not. So let's take a look at the side angle side rule. So in this case, we're still asking for 6 pieces of information, 3 for triangle 1 and 3 for triangle 2, but we're asking for 2 sides and an angle. So we're asking for side A, angle C, and then side B, and we do the same for triangle 2, and then we do the similar comparison and we determine whether or not they are congruent. You can see there are various different combinations of side angle side, so you can have ACB, you can have ABC, you can have BAC, okay? And then we move to the congruence by angle side angle, which is similar to side angle side, but we're asking for 2 angles and a side. So once again, 6 pieces of information, 2 angles and a side for triangle 1, 2 angles and a side for triangle 2, and we check whether both sets are equal across 2 triangles, and that will tell us whether they're congruent or not. And once again, there are different combinations for angle side angle there, and they're all covered here in different flowcharts. And then finally, we have congruence by angle side. This is where we have 2 angles and a side, similar type of thing, 2 angles and a side for triangle 1, 2 angles and a side for triangle 2. We check everything and we determine whether or not they're congruent. And once again, just note that the names for the angles and the sides are super important. And these are the combinations for angle side. There are 6 of these. We have congruence using the hypotenuse length rule. And here we only need 2 pieces of information for each triangle because we already know that it's a right angle triangle. So one of the angles is already given to us in that sense. So we have 2 pieces of information for triangle 1, the hypotenuse and side A. 2 pieces of information for triangle 2, the hypotenuse and side A. Check whether they're both equal, and if they are, they're congruent. The other combination is hypotenuse and side B. So similar type of thing, but different variables, and we're asking for different pieces of information, but we're doing the comparison and the same type of determination results. So the similarity algorithms look pretty similar to the congruence algorithms. So we're going to walk through the different types of rules as well. So you can do similarity by angle. So we're asking for 2 angles for 2 different triangles, angle A, angle B, angle A, angle B in this case. If both of those angles are the same, then we have similarity. And there are 3 different combinations of pairs of angles there, so we cover them in 3 different flowcharts. We also have similarity by side. So here we need 3 pieces of information per triangle, the 3 sides. And notice in this case, with the compound decision step, that there is a ratio operation happening here. So rather than just taking one variable and comparing it to another variable, like we had seen in all our previous flowcharts so far, we are actually performing an operation on the variables before we do the comparison. So we put brackets around it. We're doing the ratio between the 2 side A's across both triangles, and that has to be equal to the ratio between the 2 side B's across both triangles, and then the ratio between the 2 side B's has to be equal to the ratio between the 2 side C's. So the way SSS works, the ratio between corresponding sides across both triangles need to be the same, and that's what this step is doing here. A similar thing happens with side angle side for similarity, asking for 3 pieces of information, a side, an angle, and a side. And then the way this works is if the angle is equal and the ratio between the sides are equal, then they are similar. So here we form a ratio between the 2 side A's across both triangles. We're checking whether that's equal to the ratio between the 2 side B's across both triangles, and the angles have to be the same. And there's various combinations of SAS for similarity. And those conclude all of the congruence and similarity algorithms for triangles. The key point to note is that we are gathering quite a few pieces of information from the user. We are assigning it to different variables. Those variables match with how we've chosen to label the triangle to begin with, so that we can match up the sides and angles between the 2 triangles, so we're not comparing one angle to another angle that's not the same. And then our compound decision step here involves an AND operation together with comparing variables directly being equal to another variable, and also ratios between variables being equal to other ratios between other variables.